Now, today we are going to do another part of the chapter. All right, it's actually called the chemical changes. Now, before I go on to the question, okay, just want to check how many of you actually watched the video in the e-learning portal. Honestly, Kirana did, very good. Aaron also did. Hao Lun did, good. Yeah, Andrea as well, very good. Now, if you have watched that, that will be a lot easier. However, if you have not, okay, let me just run through a quick summary. Okay, I have prepared slides for this topic. Okay, I will be sending you notes next lesson. Okay, let me prepare some notes for you because many of you don't have your textbook yet, right? I believe. How many of you bought your textbook ready for science? I understand that if you buy your science textbook, maybe you also have access, right, to the digital version. Okay, hopefully that is correct lah. There's a digital version. So now, if you look at the slides here, we are learning about physical and chemical changes. In your textbook, it's called chemical changes, but you need to know how to differentiate between them, physical and chemical change. Last week, we started already, correct or not? Last week, we started with physical and chemical changes, just a very simple set of questions that I actually gave you. So what are physical chemical changes? Okay, the important thing to know, what you are learning in this topic, you must distinguish between physical and chemical change. Then use word equation. Word equation I'm not covering yet. Today we are doing something else, okay? Word equation will come after that. Today we are going to learn about the chemical change that's caused by heat. Okay, so for heat, we can call it thermal decomposition, combustion, okay, as well as oxidation. There is also another chemical change that you must know. It's actually due to exposure to light. Okay, so basically you need to know photosynthesis, photography. Now the word photo, okay, or that word inside the photosynthesis and photography already suggests it has got to do with light, right? Then another chemical change is caused by passing electricity through the substance. So you pass through electric current through the substance, you can break it down. All right, that process is known as electrolysis. So in total, you have thermal decomposition, combustion, oxidation, photosynthesis, photography, and electrolysis. All right, so all these you need to know. We are covering this lesson. Hi, Bernie. Yeah. Thank you for turning on the camera. Now, so last week we talked about physical changes as well as chemical changes, right? So physical changes just has got to do with the appearance. Nothing is really changed about that thing. Okay. For example, melting of ice into water. That's a change of state. It's still water. Water is made of H2O, 2 hydrogen and 1 oxygen atom. So when it is in the state of ice, it's known as solid water. In liquid state, it's liquid water, but it doesn't change its chemical composition. It's still H2O. Okay, so if I let it undergo chemical changes, for example, if I break water down into hydrogen and oxygen by passing electricity through the water, okay, that is called electrolysis of water. That is a chemical change. Water is no longer H2O there. Okay, what you are getting are new products called hydrogen gas and oxygen gas. Is that clear? Water is being decomposed into hydrogen and oxygen in electrolysis. That is called a chemical change. All right. So physical changes just got to do with the appearance, basically. Okay, when it involves chemical change, new substances are formed. Right. So we watched this video last week as well, isn't it? Remember or not? So you see that actually you can have sodium reacting with chlorine gas forming salt. But basically the salt that we are consuming, they came from the sea. We don't usually make our own salt. All right, but it's possible to make our own. Now, so physical changes also, I'm not showing the video here because we've watched it before. It's just like tearing of paper. Okay, when we tear paper, paper is still paper. But then if we burn paper, we are getting something called ash, which is carbon. Okay, so that is a chemical change. All right. So what happens when we boil water? We talk about this as well. The changes of states, right? Changes of states is actually just a physical change. No matter what state water is in, okay, it's still made out of H2O. Okay, 2 hydrogen atoms and 1 oxygen atom, chemically combined. Okay, if you want to know how it looks like, okay, water molecule, you will learn how to draw all these things in Sec 3. Okay, some of your schools may want you to learn when you are in Sec 2. Okay, so this is how water molecule looks like, really like a Mickey Mouse shape like this. All right, water molecule cannot exist in this kind of shapes. It is not stable. Okay, you will learn this in junior college, A level. Okay, so you are supposed to remember water molecules looks like this, cannot be arranged in this way. And it has got to do with some bond angle thing, bond energy thing, repulsion thing, attraction thing. All this you will learn in JC. I know a lot, you have a lot of question mark in your head already, right now, about how come like that, why repel? How come oxygen must be like that, cannot be another angle? Yeah, I know you pretty well, and like you have a lot of question mark. Okay, so you'll be asking me questions after this. Okay, save your questions for later, okay? So just accept it for now. Water, because of certain bond energy, certain repulsion, it takes this particular shape. Right, so a physical change, this is the proper definition. It's a change in which no new substance is formed. All right. Okay, and then physical changes are usually reversible. So I can get back my ice even though it has melted into liquid water. I just need to put the liquid water into the freezer. That's possible. Okay, so cutting a piece of cloth. Okay, some of you might think, a cut piece of cloth is already permanent, right? If you can't change it back, but we can remake the cloth again. Paper as well. I can tear the paper, but I can make new paper again, isn't it? Yeah, there's a way to go about doing it. Not too difficult. Now, so this one, you have seen the video last week. Okay, it's a chemical change because you no longer have your sodium looking like a silver piece of metal. You no longer have chlorine gas looking like this, okay, greenish yellow gas. Now, when they combine, they form something that we call sodium chloride. This is salt that we are eating in our food. Okay, all the savory food contains salt. All right, and salt is actually made of sodium and chlorine. If you are interested to know, and you are going to learn anyway, okay, sodium, I think you already have learned this in Sec 1 as well. Okay, sodium in the periodic table, okay, the symbol is capital N, small a. Chlorine, okay, is capital C, small l. Now, chlorine exists as a gas, so it must be a diatomic molecule gas. Okay, why like this? Because it's not stable on its own, being an atom. So it can only be stable when it exists as diatomic molecules. This is a Sec 3 work. Okay, so not to worry. You just need to know chlorine has this formula. All right. Some schools already teach students about formulas. Actually, in your syllabus in Sec 2, you only need to learn word equation. Word equation looks like this. Okay, so you have a sodium and then plus, right? Plus, okay, chlorine. And it forms this white substance, or you can say white crystals. Okay, this is known as sodium chloride. Sorry. Okay, if you are talking about the formula is NaCl. Any question here? Okay, so I'm just telling you how the formula is written. If you're asking me whether you need to learn this in Sec 2, no. Okay, you only learn this in Sec 3 unless your school chooses to bring down the Sec 3 topics to lower secondary to teach you. We have cases like that. Okay, we have cases like that. I'm not surprised. Okay, if you're just talking about the lower secondary syllabus, word equation is sufficient. Yeah. So these changes are usually irreversible. All right. So we call a chemical change a chemical reaction. Okay, so these reaction can be written as a word equation like I showed you just now, right? Okay, sodium plus chlorine upon heating, you get sodium chloride. This is known as a word equation. So word equation, all you see is actually the words. So when you see a word equation, last lesson, I also talk about before and after the arrow. So before the arrow, these substances are called the reactants. After the arrow, it's our products. Sometimes you have one product, sometimes you can have more. Okay, sometimes your reactant can be just one solo agent. Okay, breaking down into more products. Okay, so it really depends on what kind of chemical reaction we are referring to. All right. So these are the products. Okay. If I want to fit in the symbols, okay, just now I have shown you. Now, do you all know why I have written my CL, the L this way? Anybody knows? Sheena, do you know? Don't know. Who wants to make a guess? I know usually we put down L this way, right? Correct or not? But we cannot write it this way. Have y'all been told? Kaden, do you know? Kaden? Don't know. Don't write your L this way. Okay, in O-level, they're going to mark you wrong because this can represent a capital I. All right? This can represent a capital I. Yeah, very good. How Lun, you're right. The L can look like capital I. You're right. Okay. So usually you can see books writing the L this way, or they write the L like I did over here. Okay, not this way. This is the wrong representation. Yeah. All right, so let's go on. Okay, arrow shows direction of change. So it's a before reaction and after reaction. Okay, now there are some conditions required over here. So I'm going to erase this one, not necessary. Okay, the factors needed for the reaction to occur, there must be heat. If there is no heat, the reaction will not take place. Okay, so this is actually a heat-dependent kind of reaction. All right, it depends on the availability of heat or presence of heat. Right, so chemical changes can be caused by heat, light, okay, electricity also. All right, so when it's got to do with heat, we call it thermal decomposition or combustion or oxidation. So all these reactions be classified under heat. Why? Because you need to have heat in order for this to take place. For photosynthesis and photography, okay, the necessary condition will be light. So light is not there means the reaction cannot take place. Electrolysis, of course, presence of electricity. So far, so good. Are you following? Yeah, good. Thank you, Enla. Yeah. So under thermal decomposition, okay, a substance breaks down. Okay, take note. Thermal refers to heat. In primary school, you always talk about heat, right? But in secondary school, you will hear a lot of your teachers mentioning thermal. They will say that don't use the word heat. When you do physics next year, okay, suppose you are doing physics next year, okay, your physics teacher will tell you, okay, refer to the word thermal, don't use heat, or try to avoid using heat, and they will explain to you why. So in thermal decomposition, okay, decomposition, we know that in primary school you learn decompose means what? Breaking down, right, into simpler substance. Similarly, in this case, thermal decomposition. A substance breaks down. Okay, we say decompose, so this one is like